Hello there, Des here from GMIT Letter Frac with another of our DCG SOLIDWORKS tutorials. Now just before we start, if you'd like more information on the degree programs we offer in furniture design, wood technology or teacher education, then please see our Facebook or Twitter pages. So in this tutorial we're going to run through how to model this parametric dovetail box. So it's the parameters I want to focus on in this video. I show just how quickly you can model an otherwise complicated project like this. It's actually got 4 sets of dovetails which can be really sped up with the use of both parametric modeling and also multi-body part modeling. So let's begin. Now moving over to SOLIDWORKS, the first thing we're going to do is actually set up some reusable measurements called parameters. So to do this we will go to Tools and Equations. And what we're going to do is set up a thing called a global variable. So by clicking in this box that says Add Global Variable, we can give a name to our variable. So I'm going to call this box height and set the value to be 89, enter. Click again, this one is going to be box length, and let's set that value to be 220, enter, click, and we call that box depth, and let's set that to be 335, enter, and at any point you can of course go back and click these and edit them. I just have a typo there, so let's fix that. I also want one called material thickness. So let's set the thickness to 15. And one more, we're going to set up one called dovetail slope. And let's set that to 8 for now. So there we have it. We have a number of reusable parameters or equations or variables set up. So let's press OK. And we can begin drawing. So I'm going to start a sketch of a rectangle on the front plane. And I'm going to draw half the front. I'm not going to draw the entire front of the dovetail box. I'm just going to draw half it and we will mirror it a few times later. So this is going to represent the height of my dovetail box. It's going to be 89, but rather than typing in 89, I will press equals, move along to global variables, and there we can see the parameters that we've set up. So select box height and press the green tick. In this box, I want this to be the box width, but I don't actually want to put in the full value. If you remember a moment ago, I said I'm only modeling half the box for now. So what we'll actually do is type in equals, go to global variables, box width, or box length I should say, and divided by 2. Press the green tick. There we have it. So you remember my box length was set to 220. By putting in that equation, it actually sets it to 110, which is the value I'm after. I'm happy with that, so let's approve that. And go to Features, Extruded Boss Base, and rather than giving it a value of 15, let's tell it to equals, global variables, material thickness 15. So let's now start adding on some of the joints. So I'm going to begin a sketch on this surface. And let's zoom in and trace a portion of the element that's to be removed. So what I want to do is use the parameters to also drive the shape and size of these joints. So if I dimension this line, just tap escape, try that again, dimension this line, rather than putting in 15, of course, I'll hit equals, global variable, material thickness 15. At least that will now be linked to the thickness of the material. When it comes to this line, I want the joints to be evenly spaced along the overall height of the component. So I need to link those. So to link those, I will set up a dimension for this line and use equals, box height, and in my case, divided by 7. So that means that that dovetail is always going to be 1/7 the height of the overall box. Let's now set up the slope. If I had an angle, I could apply the angle, but I don't. So here's how to set up a dovetail with a slope rather than an angle. Use a center line, and starting at this point, come across, making sure that the line is horizontal, and then move up vertically until you intersect and drop the second point onto that line. Let's now set this vertical line to have a value of 1 millimeter and this horizontal line to have a value of equals dovetail slope. So now that's the slope of the dovetail, which is typically either 1 in 6 or 1 in 8, depending on whether you're dovetailing hardwoods or softwoods. But you can easily change the parameter, the dovetail slope parameter, to change this from 1 in 8 to 1 in 6. So let's start drawing on some more of the dovetails. Let's draw the second one on now in a moment. To do that, this gap is also going to be, just tap escape, is also going to be 1/7 the overall height. But rather than going through the motions again, I can simply type in equals, then click this dimension. Press the green tick. If any of those points just get in the way, simply drag them out of your way. I want to make sure that this point remains perfectly vertically aligned to these other points. So I will hold Control, select that point and select that point and make sure they're vertically aligned. And let's just do our trick again with the slope. So a horizontal construction line and a vertical construction line, and a parameter here of 1, and a parameter here equals this 8. So the remaining number of dovetails are done in the same way. That line needs to be vertical, so I'll click it and tell it to be vertical. This line needs to be the same measurement, so equals this dimension. And I don't have to do any more of those slopes because I have a slope set rising and a slope set that falls. So I can simply hold Control, select this sloped line and that sloped line and make them parallel. So I have 2 more joints to do. I'll do those pretty quickly. And remember, anything that is blue needs to be defined. So I can see here that this blue line, as I drag it, it moves left and right. I don't want that to happen. So what I'll do this time, just to use a different constraint, is hold Control, select this vertical line and that vertical line, and make those lines collinear. Holding Control, I'll select this bottom slope and this bottom slope, make those parallel, and do the same for these top 2 lines, make those parallel. So one more dovetail to remove. We'll use a collinear constraint here. And one more parallel constraint here. And let's just dimension this last gap to be equals this dimension, and we're done. So now let's use that to extrude cut out the joints. So we will go to Features, Extruded Cut, and I will select the sketch. In my case it's sketch 3. Press the green tick and we're set. Now before I press the green tick, I want to make sure that rather than just leaving the depth to 15, I want this to be linked. So if I ever make the material thicker, I want the extruded cut depth to follow suit. So let's set that to be equals material thickness. So there you have it. Let's test our parameter. If we go to Tools and Equations, and let's change the overall box height to 150 and press OK, you can see it behaves exactly as I want it to. The overall part gets taller, the joints remain centered, and they all, each element remains 1/7 the overall height of the piece. So let's now prepare the other half of this joint, but we want to do so as quickly as possible. So rather than starting from scratch with another part and hoping the joints fit when we bring them together in an assembly. Let's make them here and use these dovetails to cut the pins from the other piece. So we'll start a sketch of a rectangle on this face. And what I like to do is just draw the rectangle anywhere for now and use the collinear constraint by holding Control, select the top line and the top line, and make sure those lines are in alignment. Also this line and that line, let's make those collinear. Let's set this dimension to be equals material thickness. And finally, let's do the same for the bottom. Let's set that line and that line to be collinear. The reason I do that, as opposed to latching onto the corner, that corner is only there because I cut the dovetails out. But later, if I were to suppress or hide that feature, it would throw up an error. So as it stands now, this shape is not relying on the extrude cut for its existence. So let's go to Features, Extrude Boss Base. Let's flip it into the right direction, and for a distance, let's give it equals box depth divided by 2. Now before I commit to this, I will unselect merge result, meaning that those are two separate solids. Over here I can see solid bodies 2. I've got one component to the right, highlighted in blue there, and now one to the left. So to cut the joints from each other, what we can do is go to Insert, Features, Intersect. Select the two solids, and then make sure Create Both is selected and press Intersect. I also want to deselect Merge Result at the bottom and press the green tick. What I now have is a series of bodies. In this case, intersect 3 is the set of tails, the pins I should say, and all the others represent the tails. So I'm going to hide that body for a moment, and you can see what's left are these bodies. But as a function or as a result of that intersect feature, the 3 tails themselves have become separated from the base piece. So let's go to Insert, Features, Combine. Make sure it's set to Add and simply click all those solids to stitch them back together. Press the green tick and we're done. We now have 2 solids perfectly jointed. And as I change a parameter, Tools, Equations, Parameter, let's make that 200. Both will update correctly. The joint will update on the original piece as well as on the new piece. So let's now mirror these over. So what we'll do is go to Mirror, and the mirror face plane will be this face there. And I do not want to mirror features, I want to mirror bodies. So expand bodies, and the bodies I want to mirror will be this body and that body. Make sure Merge Solids is deselected. I will now do the same in the other direction. Hit Mirror, use this as the mirror face. Bodies to mirror will be all 4 bodies in this case. Press the green tick. And there we have it. In a matter of seconds, we have an entire dovetail box created. So obviously the real dovetail box will not be split like this. So I will go to Insert, Features, Combine, and click those 2 and add those back together. And perform the same feature 4 times. So just to test the parameters, let's call up the equations menu again. Let's make the box length go significantly longer to 500. The model updates correctly. Let's go back and change that to material thickness of 25. Everything works perfectly. So there we have it. The last thing I'm going to do, seeing as we're working with materials, is have a quick run through how to add material appearances. Now if we expand the Appearances, Scenes and Decals Manager and press the push pin to make sure it stays open, expand Appearances, Organic and Wood. So if I want to put beach onto this component, select beach and all the various different beach finishes appear on the right hand side. Now if you click and drag beach and drop it onto that solid, as I move from left to right you can see all the different options. I don't want to add it to the entire part, nor do I want to add it to the entire body. If you want realistic wood grain, what I recommend is adding it face by face. So drag and drop it onto that face, drag and drop it onto that face. While we're here, let's change from Polished Beech 2D to Polished Peach End Grain and drop it onto that face there, that face there, and that face there. Most of the time it will appear correctly, but you do get the odd time where the grain actually is going in the wrong orientation. So to fix that, simply click the surface, and what I like to do is press the drop down arrow beside Appearances and press the little swatch, the little sample. By the way, that X is how you remove the material, but this little sample, press that, it'll allow you to edit it. So use these drag corners to resize the grain, click and drag anywhere inside the frame to remove or place it, or use this yellow sphere in the center to drag and rotate the orientation of the grain. So here's the dovetail box after I've applied two different materials for contrast and I have rendered it. You can see that the main image shows the box using the dimensions that we've added a moment ago, but up in the top right hand corner, having changed a single parameter, the entire box with all four sets of joints and all associated geometry has updated almost instantly. So thanks for watching. If you've enjoyed that and want more information, then please see our GMIT Letterfact YouTube channel where you'll find many more SOLIDWORKS videos.